Astronomy is the study of the planets, stars, and everything else in space, and is one of the oldest natural sciences in existence. From ancient civilizations simply looking up at the night sky, to modern astronomers using a telescope capable of seeing 15 billion light years away, astronomy has always been an important and fascinating part of human history. In its earliest form, astronomy was closely tied to mythology. Before there were any kind of scientific explanations for the mysterious moving objects in the sky, it was attributed to the divine. But ancient astronomers paved the way for future generations who were able to build upon the collective knowledge of their ancestors. The word planet comes from the ancient Greeks, who used the term wandering star to refer to anything in the sky that moved relative to the seemingly fixed stars. As well as the 5 planets visible to the naked eye, this definition also includes both the sun and the moon. It also excluded Earth itself, which was thought by most to be the centre of the universe, up until as recently as about 500 years ago. Of course, aside from the Greeks, other prominent civilizations were responsible for their own innovations and discoveries. The Babylonians were perhaps the first to track the movement of the planets, while Chinese observations of Jupiter directly formed the structure of the Chinese calendar, among other things. One of the most fundamental questions faced by ancient astronomers was determining the shape of our planet. Now, you may have heard somewhere that Christopher Columbus discovered that the Earth was round. Thankfully these days most people know that this is a myth. Long before the time of Columbus, all educated people knew that the Earth was round. I guess some things never change. In fact, the earliest known suggestion of the Earth being round was from more than 2,000 years ago by the Greek philosopher and mathematician Pythagoras. You know, the triangles guy. He didn't actually have any evidence or logical reasons though, he just thought that a sphere was the most perfect shape and therefore that's what the Earth is most likely to be. The first to offer any kind of evidence of a spherical Earth was Aristotle in 350 BC. He noticed that during a lunar eclipse, when the Earth casts a shadow on the moon, the shadow is curved. As well as this, he noticed that stars appear differently depending on the observer's location on Earth, writing that some stars that are visible from Egypt are not visible from Europe. Another Greek by the name of Eratosthenes went one step further and actually managed to measure the circumference of the Earth with just some simple geometry. He had heard of a place called Syene where the sun shone directly down a well at noon on the summer solstice, casting no shadow whatsoever. This is due to its location almost exactly on the Tropic of Cancer, so the sun would be perfectly overhead. Eratosthenes measured the angle of a shadow in Alexandria at about 7 degrees, meaning that the distance between the two cities represented about 1/50th the circumference of the Earth. The distance was known to be 5,000 stadia, so 250,000 for the whole circumference. Since the experiment was done using an ancient unit of measurement no longer in use, the stadion, which could be converted to modern units in several different ways, the exact result of the experiment is unknown, but it was certainly impressive for 2,000 years ago. Some other ancient discoveries included calculating the distance to the moon using a technique called parallax, which is still used even to this day. It was also worked out that the reason the moon and other planets shine is from reflected sunlight. Most of the work done in ancient times has now been lost, but much of it is known to us because of a man called Claudius Ptolemy. Sometime around AD 150, he completed the Almagest. This was an extended documentation of the collective astronomical knowledge from the prior few centuries. It was considered one of the most important scientific works of all time. Despite how influential it was, unfortunately it did firmly cement the geocentric model of the universe among the scientific community. This model puts the Earth as a stationary object in the centre, with the Earth and other planets revolving around it. He even came up with his own model, which involved epicycles. This helped explain some anomalies in the planet's movement that weren't consistent with the current model. Skipping forward a little to the Middle Ages, which was a comparatively quiet time for European astronomy. Too busy killing each other probably. Conversely though, this was considered a golden age for Indian astronomy. One of the most important figures was Aryabhata, circa 500, who was way ahead of his time. He suggested that the Earth rotates around its axis every day, asserting that it was the Earth that was moving, not the stars. But this idea didn't catch on at this time. He also managed to determine the length of a sidereal year, accurate to 3 minutes from modern calculations. Another Indian was Bhaskara II from the 12th century. His extensive work in both mathematics and astronomy was divided into 4 parts, with several chapters outlining a multitude of data on the sun, moon, planets and stars. Indian astronomy was a big influence to the Islamic world, who experienced a golden age around this time. Muslim scholars were possibly the first to really question the Ptolemaic model and even geocentrism in general. One of the most important suggestions by a Persian astronomer was that the planets and stars are subject to the same laws of physics that we are here on Earth. This may not sound like a big deal, but at the time, thinking that things in the sky could follow the same rules as things on Earth was a very different approach, especially when there were centuries of religious ideas caught up in the way people understood the so-called heavenly bodies, as they were still called in academic circles. After the Middle Ages, massive strides of progress were made in what became known as the Copernican Revolution, started by the works of Polish astronomer Nicholas Copernicus. This began with the assertion that, contrary to popular belief, the Earth was not the centre of the universe. Copernicus was by no means the first to suggest that it wasn't. In fact, it was suggested way back in 280 BC by Greek astronomer Aristarchus of Samos. However, he was the driving force that eventually led to the incredibly important paradigm shift in the scientific community, from a geocentric model to a heliocentric model, that is, with the sun in the middle. Shortly after Copernicus came a huge turning point in astronomy, the invention of the telescope. Up until this point, all observations were limited to what could be seen with the naked eye. Liking what he saw, Italian astronomer Galileo wanted to get in on the action and made his own in the following year. In 1610 he discovered 4 moons of Jupiter, which today are known as the Galilean moons, Io, Europa, Ganymede and Callisto. He originally described them as stars wandering about Jupiter. This was the first time that objects were discovered that could definitively be shown to not revolve around the Earth, giving further credibility to the heliocentric model. One of Galileo's lesser known contributions to astronomy was observing the phases of Venus. The planet has phases similar to that of the moon, based on the relative positions of the Sun, Earth and Venus. When the Sun is directly between the 2 planets, Venus is fully illuminated from Earth's perspective. Under the geocentric model, there is no scenario in which the Sun could possibly be between the Earth and Venus. In the age of the telescope, the geocentric model quickly began to fall apart. Unfortunately for Galileo, there were some who clutched onto the geocentric model despite the mounting evidence against it, the Catholic Church. Galileo's claims were said to contradict the Bible and he was tried for heresy. He was forced to recant his statements under threat of torture and was placed under house arrest until his death in 1642. Another influential astronomer of this time was Johannes Kepler. He greatly improved our understanding of the solar system with his 3 laws of planetary motion. The first law basically states that planets don't revolve in perfect circles but rather ellipses, and the sun is not directly in the middle but at one of 2 focal points. The second law states that sections of this ellipse with equal areas take equal time for the planet to move across, so a planet does not always orbit with a constant velocity. The third law shows that a planet's distance from the Sun is proportional to its orbital period, with a simple formula of p squared equals a cubed. The scientific revolution is often said to have come to an end with none other than Sir Isaac Newton and his law of universal gravitation. This showed that the reason planets orbit the Sun is the same reason why an apple falls from a tree: gravity. It's the same force of nature, both here on Earth and out in space. Even after the invention of the telescope, it would still be more than 170 years for the first ever new planet to be found. The discovery came from British astronomer William Herschel, who actually thought he had discovered a comet. He originally wanted to name it Georgium Sidus after King George III, but this wasn't too popular outside of Great Britain. Some external name suggestions were Herschel, Neptune, and the name we know it as today, Uranus, the Latinized version of the Greek deity Uranus. The man who suggested this was a German astronomer called Johann Elert Bode. He was best known for the Titus-Bode law, a now disproven hypothesis which predicted planetary distances. With the exception of the large gap between Mars and Jupiter, The laws predicted distances lined up pretty much with all the planets, including the newly discovered one. So this led to a thorough search between Mars and Jupiter as several astronomers attempted to find the supposedly missing planet. In 1801, it was thought that this task had been achieved. At the exact distance that Bode's law suggested, the missing planet was found, Ceres. The following year, yet another new planet was found in the same vicinity, Pallas. Shortly after, a third, Juno, and shortly after that, a fourth, Vesta. Astronomers became uneasy about just naming more and more new planets. However, for several decades there were no new discoveries made, and for nearly half a century, astronomy textbooks listed the 11 planets. A new celestial classification had been suggested by William Herschel in 1802, asteroid, Greek for star-like. This suggestion was almost universally adopted in 1845 when a fifth object was found, and all discovered objects between Mars and Jupiter were reclassified. These 5 would be the first asteroids in what would shortly thereafter be called the asteroid belt, which today is known to have possibly millions of asteroids. Just 1 year later, and an actual new planet was discovered, Neptune. It was discovered by German astronomer Johann Gottfried Galle, but its position had been hypothesized in the years previously by 2 other astronomers due to irregularities in the orbit of Uranus. It was this discovery that was the nail in the coffin for the Titus-Bode law, as Neptune was nowhere near where it should have been. The discovery of Pluto 84 years later would further confirm this, and ironically led to a similar dispute within the scientific community, but more on that later. The 20th century was an exciting time for astronomy due to the rapid technological advancements that were made. In the aftermath of World War II, the United States and Soviet Union got hold of German V-2 rocket technology, which the US used to take the first ever photograph of Earth from space in 1946. As the Cold War tensions between the two superpowers grew, an intense cosmic rivalry emerged, known as the space race. This competition for space dominance began in 1957 when the Soviets launched Sputnik 1 into orbit, becoming the first man-made satellite in space. The USSR had several more iconic firsts in the 50s and 60s, the first animal in space, the first man in space, the first woman in space. Despite all the firsts that were achieved by the Soviets, the US ultimately managed one of the most iconic moments in not only astronomy but in human history.
It's one small step for man, one giant leap for mankind.
Neil Armstrong became the first human to set foot on the moon. This moment in 1969 was the de facto end of the space race. Not because this was an achievement that was insurmountable, it's just that the Soviet economy began to decline in the 1970s, leaving them unable to compete. Despite a slower start, it was clear that the US had now taken over technologically. From 1972 onwards, the superpowers shifted from competition to cooperation, beginning with the Apollo-Soyuz test project. Since the space race, technology has continued to improve, allowing us to see into the furthest depths of the solar system and far beyond. There have been several major milestones in the last few decades, such as the Hubble telescope, the International Space Station, and the Mars rovers, just to name a few. In 2006, for the first time, the word planet was given an official definition, with 3 criteria from the IAU. The new definition excluded Pluto, which has since been referred to as a dwarf planet. This was done because astronomers had been finding lots of trans-Neptunian objects similar to Pluto, creating the same kind of difficulties that scientists faced over 100 years before. These objects, along with Pluto and several thousand more discovered since, are collectively referred to as the Kuiper Belt. Of course, the solar system doesn't end here. In fact, anything that orbits the Sun can be said to be part of the solar system, and its gravitational field could potentially reach 2 light years away. The theorised Oort cloud is a spherical cloud made up of billions or even trillions of icy objects and is believed to be the limit of the solar system. Estimates put its expanse at 100,000 astronomical units. This is nearly halfway to the nearest star, Proxima Centauri. There is so much of the solar system that we have still yet to explore. Even returning closer to Earth, we still don't know everything. Today we know of the 8 planets, but many of us grew up learning about 9. In recent years there have been several astronomers searching for another 9th planet, which may very well be discovered someday. Or perhaps something much bigger, such as finding signs of extraterrestrial life. With recent discoveries of water on other planets, it might not be all that far-fetched. As we continue to explore outwards, our knowledge of the solar system will continue to improve and evolve, hopefully breaking new boundaries and hitting new milestones. As time goes on, our understanding of the solar system will be shaped by discoveries and innovations of the future, for many years to come. Space exploration has impacted our lives here on Earth in ways you might not be aware of. Many technologies we take for granted these days, like the GPS in our phones, was originally a NASA technology. Looking at just how important NASA has been in shaping the world we live in is a great documentary I watched called A World Without NASA, which is available on CuriosityStream. The documentary shows just how much further behind we would be technologically if it hadn't been for NASA. You can start watching thousands of educational documentaries now by signing up to CuriosityStream, which costs just $2.99 a month, and my viewers can even get a 30-day free trial at curiositystream.com/wonderwhy. And right now is a great time to sign up because with your subscription you'll also get access to Nebula, a streaming service for independent creators featuring some channels you've probably heard of like CGP Grey, Kurtzgesagt and Wendover Productions. Nebula also has a lot of original exclusive content such as the logistics of D-Day by Real Engineering. Again, that's curiositystream.com/wonderwhy for thousands of hours of educational content. Thank you so much for watching and I'll see you next time.